Hi guys, my name is Angelo Rajadurai. I'm part of Oracle in the systems division. I'm an engineer who works in the ISV engineering organization. I've been with Oracle and Sun for the last 22 years, and I've seen this chip thing developing. What we're here to talk about today is not a tiny little change in the chip design. We are doing something completely different. We are doing something revolutionary. We are doing something very, very different that the industry is not even beginning to think about. We are not doing some evolutionary thing. It's a revolutionary stuff that we are doing. We're calling it software in silicon. What it is really pushing some software stuff into silicon. And because of that, what we're going to do is gain some huge performance gains, amazing performance gains. We are also going to do some great security gains. We are making this whole thing more secure because we're pushing software in silicon. And again, if you look at it, people are talking about big data. People are talking about data growing. What we're doing by moving software into silicon is we're going to talk about how we're going to use this to increase the amount of capacity the systems can do today. You know what we're going to do? This is not stuff that is just slideware. We have a chip looking just like that, which does all of this today. And we're going to demo it to you, to prove it to you that it's possible. And in fact, if you want to try it, we're going to give you a way to try it today. You can come in and try it for yourself. What you're going to do in this set of videos is going to talk about all of these features and end it up with a beautiful demo that shows you what exactly this thing can do. Guys, we talked about performance. Now what we're going to talk about is capacity. Capacity, right? And why do we care about capacity? What's happening today, if you look in the industry, is that everything is becoming big, right? We're hearing about big data. We're hearing about cloud. We're hearing about everything where data size is exploding, right? We're having larger and larger disks. We're having systems with larger and larger memory. If you look at our own products, right? Today we ship a system that can do 32 terabytes of main memory, right? It's 32 terabytes. I just want to tell you a little story, right? The first system that I sold back in 90 had 5 gigs of hard drive. Right? So, but we're talking 32 terabytes of RAM, right? But that's not enough. We want to basically use the chip itself to give you more capacity. How do we do this? Again, let me go back to my chip, right? And again, just want to make sure we are not talking slideware here, right? We are talking about a chip that's available today. We have it on the cloud. In fact, we're going to love you to come in and try it out if you'd like. So basically, we have this chip, right? This is called the M7 chip. And this chip, again, has 32 general purpose cores, right? 32 cores with huge amounts of cache, 64 megs of cache and so on, right? Great stuff. What we've done, as we talked about in the last video, we have a little bit of silicon used for what we call as database acceleration, right? We're using database acceleration or DAX. We're using DAX here, right? So basically, we have a little bit of silicon used to do the DAX stuff that's around this chip, okay? What is this DAX doing? It's allowing you to accelerate in-memory 12C in-memory. In fact, if you want to learn more about in-memory, we have videos on that, right? You want to go and learn about what in-memory can do. One of the things that in-memory does is allows you to store data in both column format in memory as well as row format in memory. And one of the interesting things in the column format in memory is that we can do some interesting compression algorithms. Let's say you have a table with pets as one of the column, right? Typical table, you're a pet shop owner and you want to have pets. And let's say there's only 4 types of pets, right? So there's dogs, there's cats, there's raccoons, and there's snakes. So basically, in this column, you'd have something called dogs, dogs, dogs. I'm a dog person, so I'm hoping everybody only has dogs. But you know, randomly you get some guy owning a cat or a snake, right? So you're going to have that, but then you're going to have dogs, dogs, and dogs, and so on, right? So basically what we can do now is take, instead of saying dogs, you can say wherever I'm putting dogs, I'm going to put the number 1. Wherever there's going to be cats, I'm going to put the number 2. Wherever there's going to be raccoons, I'm going to put the number 3. And wherever there's going to be snakes, I'm going to put the number 4. So instead of this being a column of strings of dogs, dogs, and dogs repeating, what I'm going to do is make it into a bitmap with 1, 1, 1, an occasional 2, 1, 1, 1, right? Another 1, 1, 1, and then maybe a 3 or something, or 4 or something somewhere, right? So basically, this allows you to compress this column, which used to be a huge column, into a bitmap, okay? So what I can do now using this concept is that in DAX, I'm going to put in the algorithm to understand this and basically do uncompress for you on the fly. So instead of you taking this bitmap into the chip and then expanding it into dogs, cats again, writing it into memory, and then reading it back from memory, and then doing your operations, and then writing it back in compressed format, and doing all of that stuff, what I'm doing here is taking a bitmap in and doing the work as a bitmap, right? As a compressed format. So what does it give me? Two things. One is I can use up memory in a more optimal way that allows me to keep data in a compressed format. Second is the data that I'm moving from memory to chip, I'm only moving very little data, which means I'm not moving this huge column, and that means I'm conserving on the bandwidth that is needed for me to move data from memory into chip, right? So this is decompress on chip, right? This is interesting. This is where Oracle is smart, right? Typically people would say, hey, if you want to do compression, you would put compress on chip. But you know what we did? We found out that for every time you compress, you decompress the data 20 times. So what's better to put in on chip? Decompress, right? So that's exactly what we did. We put decompress on chip that allows you to decompress memory, which means you can keep data compressed in memory and move data compressed and basically have this done all in the DAX. And again, I want to remind you, DAX uses very, very little silicon, but gives you huge capacity gains. You know, we've traditionally seen anywhere from 5 to 50x compression that allows you to do it, which means if you have a 32 terabyte machine, if my math is right, you can have 160 terabytes of storage if you have 5x compression and 1600 terabytes, 1.6 petabytes of memory. If you allow DAX to do compression and the database can do this compression, right? Huge gains. How much silicon did we use? Very little. Is this thing real? It is. You can come and check it out in our cloud. And basically this is capacity increase because of silicon. Hang on, we're going to come and talk about data integrity. We're going to talk about security in silicon in the next video. Guys, you looked at how we are using software and silicon in the M7 chip to increase capacity for our systems. What you can do today is to go sign up at the swissdev.oracle.com website to register and to get access to the M7 chip today, where you can come and try out these features all by yourself, just to make sure that we are not showing you some slideware, but this is real.